Hey guys, in this video, we're going to discuss Leetcode 1293, and this is a very common coding question asked in Google interviews. So for this problem, we're going to be given the n by n matrix, and the values can be only 0 or 1. 0 means it's an empty cell, and 1 means there's an obstacle at the cell. And we can move like 4 directions, up, down, left, and right. So we're gonna need to find the minimum number of steps we need to walk from the top left corner to the bottom right corner, given that we can eliminate at most k obstacles. So as I have mentioned before, for questions like need to find the minimum number of steps, usually we're gonna use BFS. And in order to translate this problem into a BFS problem, we need to define the visited set to keep track so that we don't need to visit the same status again. So in this case, in the visited set, we need to keep track of the positions and plus the remaining number of k that we can remove, k obstacles we can remove into the status. So if, for example, if I'm at position ij and I have k remaining obstacle I can remove, then it will be a visited status. And in the future, if I reach the same status again, I don't need to redo the revisit the children of this status again. So okay, so let's try to solve it in with BFS. So same as before, like we need to use a DQ to solve this problem. Give me a second. Let me just import the needed library. So from collections, import DQ. This will be, we're gonna use a DQ to store the status we need to visit. All right, so Q will be DQ, and we need to visit the set. Visited equals to set. Okay, and so the initial status would be initially I'm adding at position. I have k. I'm at position 0, 0, and I have k status to remove. I can append this to q. Append. I have 0, 0, k, and I have moved 0 steps. So let me just add a comment. So every item in the queue will be item in the queue will be I, j, meaning of obstacles can remove, number of obs can remove, and the number of steps I have moved. So initially I'm at position 0, 0, and I have k obstacles I can remove, and I'm at I have moved 0 steps. All right. So now I have initialized all the variables I need. So while q exists, I have I, j, and the number of obstacles. Let me just obstacles equal to q dot pop left. All right. Just from that. So if I needed the number of rows and columns. Okay, let me see. Rows, number of rows equals to the length of the grid. To the length of the first row. If I equal to rows minus 1, and j equal to columns minus 1. So this means I have reached the end state, moved to the bottom left, bottom right. So I just return the number of steps. Otherwise, we need to find the children of the current status. So basically, the next move I can reach out to. So for new I and new j in the 4 directions I have. Four directions I have. I plus 1, I minus 1, plus 1, I minus 1, j plus 1, and j minus 1. So for the 4 directions, and need to double check if they are within the range. New I is larger than or equal to 0, and the new I is less than the number of rows, and new j is larger than or equal to 0, and the new j is less than number of columns, right? All right, so now we get the child node to move. So new obstacles. So we need to make sure the number of obstacles should always be larger than 0, right? So new obstacles will be obstacles minus grid new I and the new j. So if new obstacles is larger than or equal to 0, then we can move to this child status. Otherwise, if it's less than 0, which means like we cannot move to a block, like we cannot break through the obstacles anymore. So which means we cannot move to that node. So if it's larger than 0, and then we need to check if it's hasn't been visited before. So let's see. So every status will be position, number of obstacles, and number of steps. Okay, so new status would be new I, new j, and new obstacles, and steps plus 1. Steps plus 1. All right. If new status not in visited, sorry, the status wouldn't have the steps. I only have this, not in visited. If the status is not in visited, then we can just visited add the new status. IJ obstacles add the new status. And we just need to append the child node to the queue. And here I need the steps. Let me double check. So I have the step. Yep. And if I cannot reach that, I just return -1. Let me also move this here. Move this to up. The update this if condition and nothing. If it's larger than 0 and nothing. All right, so it will be a little bit cleaner. See how it goes. Yeah, it works fine. So for time and space complexity, so I need to visit all the nodes, and including like the number of grids I can remove, right? So the maximum number of status I can have is like number of rows times number of columns times k. That's the order status I have, and then that's also like that's the maximum queue size I need, and the visitor set size I need. So time and space both would be mn times k. All right, so this is the end of the video, and I'll see you guys in the next one.